Hello everyone, we are discussing circular motion and so far we have developed concept of centripetal force. Let's handle some more examples. Note on this one. There is a spring of force constant 20 newtons per meter. This end is fixed and this end is connected to a mass of 2 kg. And the whole setup is lying on a frictionless horizontal surface. There is no friction. You have connected a block of 2 kg and this 2 kg block is connected to the spring of force constant 20 newtons per meter. This end is fixed. This end is going to move in a circle and angular velocity is given as 10 radians per second. Undeformed length, natural length is 1 meter when there is no deformation, system is at rest. Length of the spring is what? 1 meter. When you rotate this thing, I hope you can feel that this whole thing is going to stretch. The question is, what is the stretching in the spring? By how much does it deform? So you need to find this x. Whole setup is in the horizontal plane. Natural length of the spring is 1 meter. When you rotate this mass, the spring is going to stretch. Question is, what is the deformation in the spring? Let's see how many of you can solve this question. No response so far. Look here, how do we handle something like this? जब आप इस ब्लॉक को रोटेट करोगे then it needs centripetal force for the rotation. Remember, this is the natural length, but as you rotate, it will look like this. So this is the circle which it forms. That's your natural length. Because of rotation, object takes this position. This much stretching is present. I've shown everything in the same figure. You can draw a separate thing. It was initially at this position. Because of rotation, it occupies this position. That means this much stretching is present, which is x, and we need to find this x. Now you know that कि अगर इसने सर्कुलर मोशन परफॉर्म करना है तो फिर इसे क्या चाहिए? सेंट्रीपिटल फोर्स. That is a requirement. There must be something which provides that centripetal force, which you know is what? Restoring force. जैसे ये x खिंचेगा इस तरफ, इस ऑब्जेक्ट पर एक फोर्स लगेगा in this direction. This was a natural length position. Natural length. जैसे ही नेचुरल लेंथ से आपने इसको आगे शिफ्ट किया, आई होप यू कैन सी द एरो. दिस एरो इज व्हाट? रीस्टोरिंग फोर्स. लेकिन एरो कहाँ पॉइंट कर रहा है? टुवर्ड्स द सेंटर. दिस इज द सेंटर. ड्रॉ नीट एंड क्लीन फिगर एंड रिमेंबर दिस इज द सेंटर ऑफ द सर्कल. सो व्हाट इज दिस फोर्स? This force is right here. The force produced by the string is providing us what? Centripetal force, Fc. C for centripetal. Now, what is spring force? Kx. Don't use minus kx. We are interested in what? The magnitude part. Negative sign stands for this. The deformation is this. This is the direction of force. This is magnitude, which is what? Kx. What is centripetal force? We have been given omega. So don't use mv square upon r. Instead use what? M r omega square. Now, those of you who could not attend this question, just give me the value of r. What is the value of r in terms of quantity is written on the board? Good. R means this is the center. Original length is 1. It deforms by x. So what is the radius? Radius is 1 plus x. K is given as 20. X you need to find. Mass 2 kg. Radius is what? Original length with this much deformation, and your omega is what, 10 square. Done. Everybody can solve this equation. That's how we answer questions based on centripetal force in uniform circular motion. Spring force is giving us this thing, mr omega square. Note down this much. And all those who form the same equation, write down yes in the comment box. But since I'm not solving this, if you got the answer after solving this very equation, then write down yes in the comment box. Only one person says yes. Now tell me, all others, do you understand this working? Yes or no? Those of you who could not, are you comfortable with this? Yes or no? If you're not, then tell me, what is your confusion? Where are you confused? Everybody is satisfied. Good. Well, we can extend this question. You can take this as homework. The same question can also be asked in this form. They gave you omega, and then the question is that find out total energy of the system. Write down this homework question for this previous one, the spring and all. You need to find total mechanical energy of the system. Remember, I am asking total mechanical energy. Put on this next question. Let's do some more practice. There is a car of 1000 kg. It is taking a circular turn, or you can say that it's making a complete circle, or simply a circular turn. And the circular turn is taken with constant speed of 20 meters per second, and the road which curves has a radius of 2 meters. It's a car of 1000 kg. It is coming with 20 meters per second. This is the constant speed. And with this constant speed as it comes, the driver of the car finds that there is a circular turn. And as he sees the circular turn of this much radius, 2 meters, he doesn't change the speed, he maintains the same speed of 20. If you maintain the same speed, then it becomes what? Uniform circular motion. Question is that, first thing, let me ask you, what force is going to provide necessary centripetal force when a car takes a turn like this? Answer this part first. You are driving a car on a road, and when it takes a turn, then what is the force which makes it possible? So you're answering centripetal. No, centripetal is the requirement. If something is taking a turn, centripetal is the requirement. I'm not asking you the requirement. I'm asking you what is that force which fulfills this requirement. As Earth rotates about the Sun, it needs centripetal force. What is that which provides the centripetal force? We say gravitational force. In the previous question, object was making a circle with angular velocity omega. So what was the force which provided that necessary centripetal force? That was what? Restoring force. Similarly, I'm asking in this question, when your car takes a turn, then what is that? Good. That's the correct answer. It's the friction between the road and tires. What is the force? The force is of friction between the road and the tire. And we need to find this friction force for the question and its direction. Write down the question. Coefficient of friction mu is point, or let's take the value of mu as 0.9. Coefficient of friction between tires and road is given as 0.9. Now write down the question. When a car takes a turn, when a car takes a circular turn, its friction between tires and road, it is the friction between tires and road which provides necessary centripetal force. It is the friction between tires and road which provides necessary centripetal force. For the given question, find out if it is possible, to take a circular turn with given speed. It is Is it possible to take the circular turn with given speed? I guess you can feel the question. You must have at one point of time felt the same thing in your life while taking a circular turn with your bicycle or bike or with a car. If your speed is very high, then it becomes difficult to take a circular turn. So the question is asking you what for the given speed for this road which has a radius of 2 meter and friction between tires and road is 0.9, is it possible that you can take the circular turn? Yes or no? And then you also need to find force of friction. Let's see how much you can attempt. No response. Let me give you a hint. अगर आपको याद हो जब हमने फ्रिक्शन से रिलेटेड क्वेश्चंस किए थे तो मैंने आपसे बोला था जब भी आपको फ्रिक्शन का कोई क्वेश्चन करना हो और म्यू प्रोवाइड किया हुआ है then first thing we do is we find maximum value of friction. I hope you remember this. Let me see how many of you can get me the maximum FR. Let's solve this question step by step. What is FR maximum? For this question, write down this in the comment box. Find the value of FR max. What is FR max? Mu n. Remember, अगर एक ही म्यू दे रखा है तो वही हमारे लिए स्टैटिक भी है और वही हमारे लिए काइनेटिक भी है. We are taking this mu. By the way, let me ask you this, which is an interesting thing. अगर अपने को दो अलग अलग म्यू दे रखा होता, म्यू स्टैटिक म्यू काइनेटिक, since car is moving, which mu you should take, mu static or mu kinetic? If they had given us two values of mu, static and kinetic, then what is the mu which you will take? And as usual, everybody is answering kinetic, but the answer is what? Static. झटका लगा होगा कई लोगों को, अरे सर आप बोल रहे हो कार चल रही है फिर आप बोल रहे हो कि काइनेटिक ना लेकर स्टैटिक लेना है। फिर से पूछता हूं इस क्वेश्चन को थोड़ा सा इंटरेस्टिंग बनाते हुए, और ये चीज हमने करी भी हुई है फ्रिक्शन के वक्त। जब आप चलते हो, जब आप मूव करते हो, तो what is the force which is responsible for that? Friction. It's a friction between your shoes and ground which makes it possible. I hope you remember that. Now, जब आप मूव करते हो तो आपको लगा काइनेटिक, आप किस फ्रिक्शन के पास जाने की सोचते? म्यू काइनेटिक. But do you remember when mu kinetic acts? If you remember, kinetic means relative motion takes place between contact surfaces. Relative motion. Now when you walk on a road, on a surface, नॉर्मल हॉरिजॉन्टल सरफेस की बात कर लेते हैं, रोड की बात कर लेते हैं, जब आप उस पर चलने की कोशिश करते हो तो क्या आपके शूज उस पर स्लिप कर रहे होते हैं? यस और नो? नॉर्मल कंडीशन में जब आप चल रहे होते हैं, जैसे मैं जब ये चल रहा हूं, तो क्या मेरे शूज रोड पर, ग्राउंड पर स्लिप कर रहे हैं? यस और नो? राइट डाउन दिस. गुड. नो. क्योंकि जब वो स्लिप करते तो शायद आपको आवाज आएगी, इस तरह की आवाज प्रोड्यूस होती. This type of sound, I hope you can hear the sound. If you cannot, then look here. This type of sound. But if no such sound appears, that means my shoes, they are not slipping against the ground. And what about kinetic? Kinetic doesn't mean motion, which you see in this case. Kinetic friction acts when relative motion takes place. जब आप चलते हो तो आपको लगा कि भाई काइनेटिक लगाना है, नहीं. जब आप फिसलते हो तब आप काइनेटिक लगाओगे. जब आप चल रहे हो नॉर्मल केस में, then your shoes and between the ground there is no relative motion, which is what? Just called static thing. Don't think, as a side note, इस part को पहले mention कर लेते हैं. एक अच्छा question बन गया आपके लिए, conceptual one. Side में कहीं पर इस चीज को note करो, and then you'll use the same concept in this. When a person normally walks on the road, normally means without any slipping and all. When a person normally walks on the road, it is possible due to force of friction. It is possible due to force of friction. But this friction is not the kinetic friction. But this friction is not the kinetic friction. Kinetic friction acts when relative motion takes place between two surfaces which are in contact with each other. And in normal walking, no relative motion takes place between shoes and the ground. No relative motion takes place between shoes and the ground. Therefore, it's the static friction, it's the static friction which acts and makes it possible for us to move, which acts and makes it possible for us to move. Kinetic friction will act when we slip. As a inside the bracket you can write this. Kinetic friction acts when we slip. जब आप स्लिप कर रहे हो, स्लिप का मतलब क्या है कि आपके शूज ग्राउंड पर स्लिप हो रहे हैं. स्लिप मतलब क्या हो गया? रिलेटिव मोशन. नाउ ये जो कार है, नॉर्मल केस में जब कार चलती है, जब नॉर्मल केस में कार चलती है तो कार के जो टायर्स हैं, हल्का सा अपन ने डिस्कस किया था, कंप्लीटली रोटेशन में डिस्कस करेंगे. दिस इज द लोएस्ट पॉइंट ऑफ द कार, द टायर. When car moves, this point, it comes at rest. We'll see the whole thing in detail in rotational motion, but जैसे आप चलते हो वैसा ये भी है. This is the lowest point, which is kind of shoes for the car. As it comes in the contact, it doesn't move. In normal cases, जब आप बहुत तेजी से ब्रेक लगाते हो और स्किडिंग की आवाज आती है, that is slipping. नॉर्मल केस में जब कार चल रही है, उस वक्त टायर्स रोड पर स्लिप नहीं कर रहे होते हैं. जब कोई आदमी बहुत तेजी से ब्रेक लगाता है, आपने इस चीज को देखा भी होगा, किसी ने अगर बहुत तेजी से ब्रेक लगाया बाइक, देन स्किडिंग होती है. When you see that skidding, you also see skidding marks on the road. एक तरह से टायर, it works like an eraser and you see all the marks on the road. That is what skidding, that is what kinetic. नॉर्मल केस में जब चीज चल रही है, आप चल रहे हैं, कार चल रही है, there is no slipping happening. Are you comfortable with this part? Yes or no? ये जो मैंने kinetic वाला पार्ट समझा दिया है, तुमको इतनी चीज समझ में आ रही है तो yes, नहीं आ रही है तो सोचना भाई, because we'll discuss this thing again in rotational motion. So right now let's come back to the question. Question, जैसे ही फ्रिक्शन की बात करेगा, हम कहां जाएंगे? FR max. कार हमारी किस प्लेन में है? It is moving in a horizontal plane. तो horizontal plane में आपको पता है कि नॉर्मल रिएक्शन कार के लिए कितना होगा? mg. Mu is 0.9, m is 1000, and g is 10, which gives us 9000. So maximum friction you can get is what? 9000. Now, who will tell me the direction of friction which acts on this for the question given, which says that this speed is constant? Write down the comment box if you know the direction of friction which is going to act on this car. That's the correct answer. People are saying anti-clockwise or clockwise. Look, I told you that speed is what? Constant. In any circular motion, you have a force tangential which acts in the direction of V. Another force which acts towards the center, FC. कई बार डिस्कस किया होगा हमने ये. In circular motion you deal with two forces, Ft and Fc. Ft का काम क्या है? स्पीड चेंज करना. नहीं हो रही, कांस्टेंट है. तो हमारे इस क्वेश्चन के अंदर Ft is 0. So if Ft is 0, Why? Because speed is constant. Constant speed is telling us that tangential force is what? Zero. तो फिर कौन बचा? सेंट्रीपीटल. और कार जब टर्न ले रही है तो आप तो उसे पुश कर नहीं रहे हो. कार के टायर्स और रोड के बीच में कांटेक्ट हो रहा है. And the force which is acting is what? Force of friction. So force of friction is the force which is acting towards the center. This is FR. Question tells us that car takes the circular turn with constant speed. That means there is no tangential force. That means only force acting on the car is the centripetal, which acts towards the center. On the car, you yourself told me that it's the friction between the tires and the road which will provide necessary centripetal force. So this FFR is going to give us FC. अब इस क्वेश्चन को खत्म करते हैं. What's the value of FC? M 1000, V 20 divided by R 2. देखते हैं ना भाई. FC M V square divided by R. 400 divided by 2, 200. 200,000 newtons. What is FC? This much. What is force of friction? This much. So who will tell me what is happening? Read the question I gave you. Can you answer the question now? Everything is on the board. Can you answer the question now? Or do you even remember the question? The question was, can this car take a circular turn? Can this car take a circular turn on this road with this speed? Yes or no? Write down yes or no. Can this car take a circular turn on this road? Well, everybody is saying yes. पता नहीं कैसे बोल रहे हैं आप यस. क्या लिखा हुआ है यहां पर? What is that which provides necessary centripetal force? Force of friction. For this car of 1000 kg to make a circle of radius 2 meter with a speed of 20, centripetal force should be 200,000. This is the centripetal force required. Now, what is that which can fulfill this requirement? Force of friction. तो आपने फ्रिक्शन से बोला कि मुझे 200,000 चाहिए. फ्रिक्शन बोल रहा है कि max I can give you is what? 9,000. Which means what? This car can not make this circular turn. It is going to skid. It cannot complete the circular arc because जो requirement है उसको fulfill करने के लिए sufficient friction present नहीं है. We'll write the statement, but just tell me, do you understand this logic? कि requirement ज़्यादा है, देने वाला कम है. क्या आपको ये बात समझ में आ रही है? Yes or no? Especially those who answered yes in the previous part. Now one of you is saying no. If you are saying no, then you have to tell me why. What basically your confusion is. If you are saying no, then it cannot be a simple no. Switch on your mic or write down in the comment box. Where is the confusion? The person is asking why we should make them equal. अरे भाई कहां से इतनी देर से वही चीज तो चल रही है. What is FC? Requirement. आपने बोला कि एक कार सेंट्रीपिटल की वजह से चक्कर लगा रही है. एक काम करते हैं, कार में से टायर हटाओ, रोड हटाओ, अपने आप घूम रही है. क्यों? सेंट्रीपिटल लग रहा है. नहीं, कुछ होना चाहिए जो उस सेंट्रीपिटल को प्रोवाइड करे. जैसे मैंने एग्जांपल दिया था अर्थ का. इलेक्ट्रॉन न्यूक्लियस के अबाउट घूमता है, आपको पता है. क्यों? Because Coulomb's force that acts between the nucleus and the electron. There must be some mechanism which makes it possible for the object to make a circle. What is FC? It's the only thing, it's the requirement part only. There must be something which provides FC. What is the force on the car? There is only one force between the rods and the tire, which is coming from friction. Since question says you have to take the turn with constant speed, force of friction will act this way. जैसे इधर लगेगा, इस friction की responsibility थी FC देने की, and therefore they are saying that these are equal. सेंट्रीपिटल ने कितने की डिमांड की? 2,200,000. फ्रिक्शन ने बोला कि मैं केवल कितना दे सकता हूं? 900. इसका मतलब जब कार सर्कुलर टर्न ले रही है, और मैंने आपको थोड़ी देर पहले बोला था कि आपने फील किया होगा इस तरह की चीजों को, हालांकि कम करना, बिल्कुल ही मत करना. If you are feeling this type of thing, this is dangerous. We don't want to feel this, and therefore we decrease the speed on a circular turn. Because of this thing only, because friction is not sufficient. We don't know about the type of road we are going to have. So if friction is not sufficient, then what will happen? The car is going to skid off the track. As it skids off the track, this is not a safe thing. So what do? You decrease the speed in normal situation. What this question is asking you, this question is asking us that, is it possible to make a circular turn on this road? And the answer is no. Why not? सामने है आपके. Write down a few lines. Hopefully समझ में आ गया होगा भाई. Write down the statement. Centripetal force is the requirement part only. Centripetal force is the requirement part only. There must be something which fulfills this requirement. there must be something which fulfills this requirement. In the given question, centripetal force will be provided by the force of friction. In the given question, centripetal force will be provided by the force of friction. But for the given data, requirement of centripetal force is 200,000, whereas maximum friction can provide is 9,000, and therefore this car cannot complete the circular turn. आई होप चीज क्लियर होगी पूरा यहां से। इसमें एक पार्ट और याद रख लेना आगे से। अगर आपने अगेन लेट मी आस्क यू फर्स्ट, सपोज क्वेश्चन में ये दिया होता कि भाई कार की स्पीड भी हम बढ़ा रहे हैं, तो और एक डिफरेंट केस हमने लिया, कार इज मेकिंग अ सर्कुलर टर्न विद इंक्रीजिंग स्पीड। स्पीड भी बढ़ा रहे हो आप, इसका मतलब टेंजेंशियल भी है, सर्कुलर टर्न भी ले रहे हो, इसका मतलब एफसी भी है। इफ यू आर इंक्रीजिंग द स्पीड, सर्कुलर टर्न तो आपको समझ में आ गया किसकी वजह से था, force of friction, centripetal. What is the force which is giving us tangential force? If a car is taking a circular turn with increasing speed, then what is that force which is providing the tangential force? Let's see who answers this. Good. That's the correct answer. Friction only. टेंजेंशियल देने का काम भी किसका है, फ्रिक्शन का। सेंट्रीपिटल देने का भी काम किसका है, फ्रिक्शन का। तो अगर कार के पास स्पीड इंक्रीज करने का केस है, तो फिर उस केस में क्या हो रहा होता, लेट मी ड्रॉ इट ओवर हियर। Force of friction will then act in this direction. If Ft is not 0. Hopefully आपने ये फिगर पहले वाला ड्रॉ कर लिया होगा. You can mention this figure under this category. If V is increasing, if speed of car is increasing, then Ft is present as well as Fc. अब फ्रिक्शन कहां लगेगा, इस तरफ। जब कार की स्पीड क्या थी, कांस्टेंट, तब फोर्स ऑफ फ्रिक्शन कहां था, इधर। ये जो फोर्स ऑफ फ्रिक्शन है, इसका एक कंपोनेंट क्या प्रोवाइड करेगा, सेंट्रीपिटल, और दूसरा कंपोनेंट क्या प्रोवाइड करेगा, टेंजेंशियल। And what about this? Which case is this? This is NUCM, नॉन यूनिफॉर्म सर्कुलर मोशन। और इस क्वेश्चन को हम किस कैटेगरी में हैंडल कर रहे थे? UCM। जस्ट फॉर योर नॉलेज यू कैन राइट दिस पार्ट। कुछ लोग बोलते हैं कि टेंजेंशियल कौन देगा? सर कार का इंजन। डेफिनेटली कार का इंजन, बट कार का इंजन दैट इज इनसाइड। Either you need to push the car somehow, so somebody from outside pushes the car, but that doesn't happen. As you accelerate the car, the tires, they are spinning fast. As they spin fast, you develop what? This tangential force. This tangential force is again coming from the friction which is present between the tires and the road. This is the side information as of now. अब हमारे इस क्वेश्चन के नेक्स्ट पार्ट की तरफ चलते हैं भाई। What you found that this is with this speed it's not possible to complete the circle. कार स्किड करेगी। So tell me, what is the maximum safe speed which this car can have on this circular road? Write down this as a question. In the previous question, find out maximum safe speed with which car can take the circular turn. Let's see who can answer this part. Remember, I'm asking you what is the maximum safe speed. By the way, इस क्वेश्चन में एक चीज और कर लेना। अपन ने इतना तो नोट कर ही लिया है इस क्वेश्चन में that this type of turn is not possible because friction is not sufficient. So the question was also that how much friction is acting. So how much friction is acting? If somebody says find out force of friction, इस वाले केस की बात हो रही है 20 की, तो रिक्वायरमेंट कितने की थी? 200,000। मैक्सिमम कितना मिल सकता था? 9,000। इसका मतलब कार क्या करने लगी? स्किड। और जब कार स्लिप करेगी, तो फिर फ्रिक्शन क्या लगेगा उस पर? मैक्सिमम। नाउ इफ दे हैव गिवन अस काइनेटिक फ्रिक्शन, रिमेंबर अगर इस सिचुएशन में अब इन्होंने म्यू काइनेटिक दिया होता तो फिर हम यहां पर FR निकालते किसके लिए? काइनेटिक के लिए। क्यों? क्योंकि कार स्टैटिक की वजह से सर्कुलर टर्न कंप्लीट नहीं कर पा रही। एज इट स्किड्स मीन्स व्हाट? relative motion takes place between the tires and the road. तो अगर इस क्वेश्चन में अब काइनेटिक दिया होता तो आप फ्रिक्शन को क्या ले रहे होते? काइनेटिक। बट आई हैव टोल्ड यू दैट दे हैव ओनली गिवन अस वन वैल्यू। तो जब भी आप स्किड करते हो तो फ्रिक्शन कहां पहुंच जाता है? अपने मैक्सिमम पर। सो द आंसर विल बी व्हाट? 9,000. But don't forget that if they have given us mu s as well as mu k, then you will find FR kinetic also. If you find that skidding takes place, then you will go for FR kinetic. अब जो अपना क्वेश्चन मैंने आपको दिया हुआ है, the question is that find out the safe speed. तो हमने बोला कि यार मान लो v is the safe speed which we can have. Safe का मतलब आपने देखना भाई, यहाँ आप एक अलग फिगर में करना, मैं ऐसे में बना रहा हूं भाई। Look here, force of friction is providing us what? Force of friction is providing us centripetal. What is that? mv square upon r. यहां से और अच्छे से क्लियर हो जाएगा आपको। Force of friction is providing Fc, which is mv square upon r. जब आपने v को इंक्रीज करने की कोशिश की, स्पीड को, तो फिर ये भी क्या होगा? इंक्रीज. The upward arrow is for increase in the values. So as you increase v, FFR increases. थोड़ी देर के लिए, so it's only 2-3 have answered this question. Before I answer this, let me ask you this. V is 1 meter per second. I'll come back to the V maximum which we need. लेकिन उसके पहले इस चीज का आंसर दो. छोटे छोटे स्टेप्स इस क्वेश्चन को समझने के लिए हेल्प करेंगे. सपोज क्वेश्चन दिया गया होता दैट V is 1 meter per second and I'm asking you what is FR, what is friction acting on the car. Write down this part first. Forget about this. V is 1. I'm looking for FR. जैसे मैंने पिछली बार V क्या दे रखा था? 20. जब 20 दिया था तो क्या मिला था? तब मालूम पड़ा अपने को कि कार स्किड करेगी. V is 1. Then what will be the value of FR? Good, बहुत सही. अगर V1 है तो फ्रिक्शन का काम क्या है? Fc प्रोवाइड करना. What is Fc? mv square upon r. What is m? 1000. What is V? 1. What is R? 2. How much is it? 500 newtons. Had the car been moving with 1 meter per second, then friction is going to give us mv square upon r, which is coming 500. तो आपने क्या पूछना है अपने आप से? आपने क्या बोला कि भाई सेंट्रीपिटल फोर्स बोल रहा है कि उसे 500 चाहिए और फ्रिक्शन बोल रहा है कि वो कितना दे सकता है? 9000. तो अब फ्रिक्शन 9000 नहीं देगा. इट्स अ सेल्फ एडजस्टिंग फोर्स. It's a very lazy guy, if you remember the chapter of friction. Since he is a very lazy guy, he says what? कि भाई तुम्हारी रिक्वायरमेंट कितने की है? 500. ठीक है, 500 लेकर जाओ. So the answer is FR is what? 500. अब कोई दूसरा आदमी आया, उसने बोला हम स्पीड को 1 की जगह क्या करेंगे? 2. तो अगर ये स्पीड 2 होती तो ये क्या बनता? 2 स्क्वायर डिवाइडेड बाय 2 which is 2 into 1000, 2000. अगर हम स्पीड को 1 की जगह क्या कर देते? 2. तो फ्रिक्शन से कितने की डिमांड की जा रही है? 2000 की. दे कितना सकता है? 9000. उसने बोला ठीक है, दिया. फ्रिक्शन क्या हो जाता? 2000. So you can see that as you increase your V, this force of friction is increasing. लेकिन इसकी लिमिट है. ये कहां जाकर बोलेगा कि अब और नहीं दे पाऊंगा? 9000. Now I hope everybody can answer. Those who could not, get me the value of V max. जहां तक सेफ है कार को चलाना. Answer this part fast now. मैंने सारी चीजें क्लियर कर दी हैं. I hope Those of you who could not answer Vmax, get the value of Vmax now. Even after telling this much, only two have responded. So the thing is, as you increase V, FR also increases. So when this V becomes maximum, V square divided by R, your F force provided by friction will also become what? Maximum. As you increase V, this increases. The last point जब safe है उस वक्त V आपका max होगा, ये भी max हो जाएगा. M is what? 1000. We need V max. Square करो divided by R, which is 2. And what is FR max? 9000. 1000 gone. V to 918. So your V max is coming root over 18 meters per second. This is the maximum safe speed which the car can have on this road. Note down this. Look at this next question. It is related to vertical circular motion, but you can answer this thing. This is circular motion in vertical plane. So the question is that we have an object of 2 kg which is released from this height of 5 meters. You release it from the incline, there is no friction anywhere. So you release it from the incline, it comes down and then starts moving in this circular plane. You can take the radius as 1 meter. The question is something like this. Suppose my hand, it represents the incline. As it comes down, it joins a circular part and then starts moving in that circle. So what is the whole thing? The whole thing is in vertical plane. So everything which you see in this question is in the vertical plane. You release the object from this height of 5 meters. It comes down on a frictionless surface. Everywhere there is no friction. This is the lowest point of the circle. Lowest point. Right when it is at the lowest point, you need to find two things. You need to find normal reaction and you need to find centripetal force. I hope the question is clear. There is an incline and the incline is connected to a circle of radius 1 meter. As it slips, it joins at this point the circle and starts moving in the circular path. Question is, right here at the lowest point, just when it starts moving in the circle at the lowest, what is the normal reaction acting on the object and what is the centripetal force? You can answer this question in 20 seconds, but I'm giving you 1 minute's time. Let me see if you can. And let me tell you, it's something which is very easy. And I'm giving you, after 20 seconds, I will give you the hint. The hint is draw the free body diagram. When the object is at the lowest point, draw its free body diagram. One, two, three, four. Only 4 responses so far. Look. This is the lowest point. That's your object. When it is at the lowest point. Let's draw the free body diagram over here. This is M. Downward force is what? mg. And there will be a normal reaction force. You are in a vertical plane. So your object, if object is over here, this duster is the object. My palm, let's say it represents the circular part. So that's how the object is. This is the object, downward force of mg. And then a force coming from the ground, from the circular track N, which is acting up. So these are the forces acting on the body. What are these forces? mg, m is to g 20, normal reaction. I hope you can see that normal reaction will pass through the center. Not a difficult thing to feel. At this point, if you draw a normal, on a circle if you draw a normal, it will always pass from the center. Now, this is coming from kinematics. If you release something from height h and if surface is frictionless, then after coming down h, standard formula है भाई, v कितना हो जाता है रूट ओवर 2gh. तो जब ये ऑब्जेक्ट यहाँ पर पहुंचकर इस सर्कल में मूव करने की शुरुआत करता, एट दैट मोमेंट जो इसकी स्पीड है वो क्या आ रही है, √2 10 5 which is 10 meters per second. लॉज ऑफ मोशन में भी किया हुआ है, वर्क एनर्जी में भी किया हुआ है। एच को इससे मतलब नहीं है, वी को केवल इस हाइट से मतलब है। यहां से यहां पहुंचने का जो v होगा दिस इज √2gh which is coming 10. So now v is 10 meters per second. अब जरा यहां देखना, जब ऑब्जेक्ट रेस्ट पर होता है नॉर्मल सिचुएशन में, नॉर्मल सिचुएशन डस्टर मेरे हाथ पर है, इस कंडीशन में नॉर्मल रिएक्शन किसको बैलेंस करेगा, mg. नॉर्मल सिचुएशन व्हेन दिस थिंग इज एट रेस्ट. अगर अपना ये m रेस्ट पर होता तब आप इस तरह की चीजों को करते हैं, वर्टिकली मूव नहीं कर रहा ऊपर नीचे कहीं भी, तो आपने सीधे सीधे बोलना होता है दैट n इज mg. हर आदमी को ये पता है, लेकिन इस केस में आपका नॉर्मल रिएक्शन mg नहीं है. क्यों नहीं है? is moving with what v and is trying to complete what a circle. अगर कोई ऑब्जेक्ट सर्कुलर पाथ में मूव करने की कोशिश करेगा तो उसे क्या चाहिए, सेंट्रीपिटल फोर्स. तो अगर अपने को यहां पर सेंट्रीपिटल फोर्स चाहिए, अगर अपने को यहां पर सर्कुलर मोशन करने के लिए सेंट्रीपिटल फोर्स चाहिए, what is the requirement of centripetal force? mv square upon r. Last few minutes देखना भाई, what is this requirement? लेकिन मैंने आपसे क्या बोला है बार बार, कुछ होना चाहिए जो ये रिक्वायरमेंट फुलफिल कर सके. और what is that? कितने फोर्स लग रहे हैं इस पर, n mg. what is net force? mg ज्यादा होगा या n? Write down this, those of you who understand this part, which force should be larger, n or mg? Write down this in the comment box fast. I have already told you that n is not mg. Which one should be greater, n or mg? I hope you are answering n. Why? अगर mg ज्यादा होता n से तो नेट फोर्स कहां लगता, नीचे. लेकिन नेट फोर्स क्या देने वाला है, सेंट्रीपिटल. सेंट्रीपिटल किधर लगता है, टुवर्ड्स द सेंटर. सेंटर की तरफ नेट फोर्स चाहिए तो फिर किसको ज्यादा होना पड़ेगा, n. सो व्हाट इज नेट फोर्स? नेट फोर्स इज n माइनस mg. देखते हैं ना, n माइनस mg over here, n minus mg. What is mg? 20. m, mass of the object 2. v, how much is v? 10 square divided by r. What is r? 1. So this is 1. This is coming what? n 220 newtons is what? The normal reaction. दो चीजें पूछी थी, क्या क्या? नॉर्मल रिएक्शन कितना है, 220. और एक और चीज क्या पूछी थी, सेंट्रीपिटल. कौन है सेंट्रीपिटल? mv स्क्वायर अपॉन r. कौन है सेंट्रीपिटल? n माइनस mg. व्हाट इज n? 220. व्हाट इज mg? 20. व्हाट इज 220 माइनस 20? 200. और सिंपली दिस. व्हाट इज सेंट्रीपिटल फोर्स? mv स्क्वायर अपॉन r. n कितना है अपना, 2. v 10 स्क्वायर डिवाइडेड बाय r. अगर कोई पूछता सेंट्रीपिटल, ये रहा. किसने पूछा नॉर्मल रिएक्शन, ये रहा. If you understand this much, then write down yes in the comment box and then you can leave. Thank you. very much.